Hi, welcome to Meetings in Math. You are here for a review of solving systems of equations using different methods. What we are going to be looking at is how do you choose the most efficient way to solve a system of equations, and how can you use more than one way to check your work. Today you'll need your Jaguar jots on 5.1 through 5.3, a pen or a pencil. Highlighters might be useful. A calculator is nice to keep things moving along quickly. Problem solving skills, your perseverance, and as always, some determination. The first thing that we're going to look at is this chart, where I'd like you to assess how you've been learning so far solving systems of equations. Tables, graphing, substitution, and elimination are the main ways that we solve systems of equations. And I'd like you to decide if you've never heard of it, you've heard of it, you can do it with help and notes. I can do it with notes. I can do it without notes. Or if you are able to help other people. And then I'd like you to list the methods in order from least time efficient to most time efficient according to you, and then be prepared to defend your choices in class. So I'd like you to pause the video right now and take a moment to evaluate your understanding of these four methods. So now that you've evaluated your understanding of these four methods, we're going to go ahead and explore them. Please keep in mind that you may not have used all four methods this year. Sometimes we don't do all four methods, or we've decided to focus more on one and not so much on another. So if you aren't familiar with all four methods, that's okay. Pay attention to the ones that you know best. On this first one, we're going to be looking at elimination and then using a table. So in elimination, the idea is to get one of the variables to go away. That's why it's called elimination, by using addition or adding the two equations together. So if we look at this, we look at negative 5x and 5x. Those are additive inverses. And so those are going to eliminate, leaving us with just the y's. So let's go to a document camera and get a better idea. It does look like there are some typos maybe on some of them. So this should be negative 5x plus 2y and 5x plus y. So you can see that negative 5x and 5x are additive inverses. And so what will happen there, let's go ahead and rewrite them. So negative 5x plus 2y is equal to 13. And 5x plus y is equal to negative 1. And now we're just going to add in our like terms. So negative 5x plus 5x is 0x. And so we're not going to do anything there. But 2y plus y is a 3y. And 13 minus 1 is a 12. And now we just have a nice, simple one-step equation that when we divide both sides by 3, we get y is equal to 4. So remember that the answer to a system of equation is an ordered pair, xy. And so now we have a portion of it. We know the y portion is 4. So now to find the x portion, if you recall, we're going to take our y equals 4, and we're going to substitute it into one or the other equation. It doesn't matter which one. I'm going to pick the second one for the only reason that it doesn't have a bunch of negatives and the numbers are smaller. And we always rewrite the equation so that if we make an error in how we copied something, it's easy for us to find. So 5x plus, and then always substitute in parentheses, equals negative 1. So we are going to subtract 4 from both sides. So now we have 5x is equal to a negative 5. And then when we divide both sides by 5, x is equal to a negative 1. So our x is now negative 1. So our answer is negative 1, 4. So that was solving by systems of equations by elimination. And if it wasn't something you've seen before, and this is the first time you've ever seen it, that's okay. But that's how you do it. If this is not the first time you've seen this, this is something that you need to make sure you understand, and you understand well. So now we are comparing elimination to a table. So let's go ahead and look at how do we solve this with a table. So you'll notice on the next page, there's a whole lot more room to do this problem, and that's because tables take a whole lot more room. So we know what our x is going to be. So what we're going to do is we're going to have an x that we know is the same for everything. Because what we're trying to find is where is x and y the same for both. And then we're going to take our first equation, so negative 5x plus 2y is equal to 13. And we want to know why when that is happening. And then we also want to know why when we're doing our second equation. 5x plus y is equal to -1. So we want to know why when those two situations are happening. And it's really just guess and check. I almost always start at x equals 0, usually because I'm hoping, but there's really no good way to know where to start when you're doing these problems. And so we're going to put x equals 0 into the first equation, -5x plus 2y equals 13. And it is imperative that you write down which equation you're putting it into so that you don't get confused. And so I would write down which one we're working on right now. So -5 times, and we are working with x being 0, plus 2y equals 13. And now I'm solving for y because we want to know what y is. So this is 0. So just 2y is equal to 13. Divide by 2, y is 13 halves. Not overly helpful. So this is the point 0, 13 halves. So this point needs to be 13 halves if this is going to work. So what is x when x is equal to 0? And now we're going to put it into the second equation. So 5 times, again, it's still 0 because we're looking for that point of intersection. So that's 0. So y is equal to -1. So this is the point 0, -1. This point and this point are not the same, so it is not a solution. So we go try another point. You don't really have any good ideas of what do I try next. So let's try x equals 1. And you do the same thing. And you do it for each point. So why don't you guys go ahead and do that and then come on back and let's see what you got. Just to make sure you're going in the right direction, this is what your substitution should be looking like. And let's finish that problem now. So you can see that y is equal to 9 and y is equal to -6. This was not very helpful. When x was equal to 1, we ended up with 9, which is the point 1, 9, and we ended up with -6, which was the point 1, -6. They're not equal. So for the problem before, we actually know what the answer is. So let's go see what happens when we actually pick the right number, which was -1. So let's let x equal -1, and let's put it into -5x plus 2y equals 13. And let's also put it into the second equation, 5x plus y equals -1. So why don't you guys go do that and then come on back and let's see what you have for answers. So when you finish that, you should have felt really good because you should have seen that y was equal to 4 for both of them, which is exactly what we wanted. So when we come back up to our table, you would have put 4 and 4. So this is the point 1, -1, 4, and this is also the point -1, 4. So our solution to this equation is -1, 4, because it makes both of the equations true. So what do you think was easier? Even if you've never seen elimination before, I'm hoping that you would see that elimination was much easier than a table. While a table definitely gives us an answer, there's a ton of work involved. Does a table work? Yes, absolutely, it works. But you had to do a lot of guessing and checking to do the problem. We were able to reduce that guessing and checking because we already knew the answer. So let's go ahead and look at the next problem. Okay, so let's do this one. This one says solve the equation by substitution and then elimination. So let's look at it first. It's 5y equals 15 minus 5x and y equals -2x plus 3. Let's look at the second equation. Remember that there is a card that on one side it says y and on the other side it says -2x plus 3, and we can choose which side we want showing at any time. So up here in the first equation, the y card is showing. It says 5y's is equal to 15 minus 5x, but we're going to change those y's into saying -2x plus 3. That's what we're going to have it say later on. So let's go ahead and rewrite this right now. We are going to change this, and it says 5y, but we're going to change that card in just a second, equals 15 minus 5x. So that was saying y, that card right there, it used to say y, but we're going to change it to saying negative 2x plus 3. So instead of y, this one, it's going to say negative 2x plus 3. And now we're going to solve this equation. So we no longer have any y's here. It's all in x. Now we can solve it. So 5 times negative 2x is a negative 10x. And 5 times 3 is 15. And we don't do anything on that side because it's all simplified. And now we're solving an equation that has variables on both sides. So I have a negative 10x and a negative 5x, and I think I am going to move my negative 10x's over. So I'm going to add 10x to both sides. So negative 10x plus 10x is 0. So now I have 15 equals 15, and 10 minus 5 is 5x's. So I have my x's right here, so I'm going to subtract 15 from both sides. So now 15 minus 15, even though it was this 15 I was getting rid of, 15 minus 15 is 0. And I'm going to subtract 5x, or excuse me, divide by 5x. And I end up with 0 is equal to x. And that's fine that I ended up with 0 equals x. It is a number. 0 is equal to x. So right now I almost have my answer. I need to just figure out what y is equal to. So I'm going to take that, the fact that x is equal to 0, and I'm going to put it into one of the two equations. It doesn't matter which one I put it into, does it? But this one's already very nicely laid out for me, so let's put it into that one. So now every time I see an x, I'm going to put a 0. So y equals negative 2 times 0 plus 3. So y equals, that's 0. So y is equal to 3. So my answer is the ordered pair 0, 3. So that was by substitution. So let's go ahead and just write that. Let's go ahead and write that right here. I'm just going to turn my thing. So that's by substitution. Now, elimination is a little more difficult. In elimination, I have to get my x's and my y's to cancel somehow. And that's not always easy to do. So I need to figure out a way to make that happen. I'm really close though. If these were additive inverses, that would happen. So I need to come up with a way to make that happen. So one of the first things I do is I get all my x's and all my y's to the same side. So let's rewrite this and get started on that. So 5y is equal to 15 minus 5x. So I need to add 5x to both sides. So this can be written as 5x plus 5y is equal to 15. Same equation, just rewritten, okay? Second one, y equals negative 2x plus 3. So I'm going to add 2x to both sides. So now I have 2x plus y is equal to 3. Now remember, it's all about having additive inverses, and I'm super close, but not quite there. I have my y and my 5y. If this was a negative 5y, I'd have additive inverses, and so that's what I'm going to do. I'm going to take all of this, and I'm going to multiply all of it by negative 5. If I do that, I should get additive inverses. So I'm going to take this, it's kind of messy, and it's going to be 5x plus 5y is equal to 15. And I'm going to take this, and it's going to be negative 10x. 5 times negative y is a negative 5y, and 3 times 5 is negative 15. So now I have 15 minus 15, which is 0. 5y minus 5y is 0. And 5x minus 10x is a negative 5x. So now I can divide by negative 5, and x is 0. Looks familiar. So now I'm going to go put that into one of the original, not one of the changed ones, but one of the original. I'm going to do it back into y equals negative 2x plus 3, just like I did before. So y equals negative 2 times 0 plus 3. So y equals 0 plus 3. So y is 3. So I have my answer, 0, 3. So this is elimination. Let's go ahead and write that on the side. And some people really prefer elimination. Even though there were some extra steps to do here, they still prefer it. It's really up to you which one you prefer more, depending on what you've learned. I personally prefer substitution in this one because I already had a y equals. This very last one, I would like you to decide whichever choice you want to do. Go ahead and pause the video, try it out, and then I am going to use my method of choice to solve it. And so depending on what I've learned, I would probably go towards elimination on this one, even though there's an extra step. I would take my very first equation and I would multiply everything by negative 3 so that it was negative 9x minus 3y is equal to negative 33. The numbers might get a little bit big on this one, but I think that it's a pretty efficient method. So now that those are gone, I end up with a negative 3x is equal to negative 33 plus 24, which is 9. And then divide both sides by negative 3. I end up with an x equals negative 3. And so now I take that and I substitute it into either one. I'm going to substitute it into my first equation before I did anything to it. So every time I see an x, I'm going to put a negative 3. So I have 3 times negative 3 plus y equals 11. So I have negative 9 plus y equals 11. Add 9 to both sides. Y is equal to 20. So my answer is negative 320. So that was by elimination, but that is not the only way to do this problem. I know I said I would show you my favorite way, but you can definitely do this one by substitution. If you did it by substitution, you would have made this right here, y equals negative 3x plus 11, and then substituted that into this equation. Whatever way you did it, your answer would be negative 320. This here had a lot of review in it and a lot of problems done in a lot of different ways. I thank you so much for showing up today and doing your very best and trying all the different ways that there are to do systems of equations. Remember, the way that you get better at these problems is to just keep practicing them. They're like a big jigsaw puzzle. As you practice them and you find new techniques, you learn new tricks and things to look for, and they become easier. It is time consuming, and you have to be willing to put in the time in order to get better. Thank you so much for joining us, and remember, be kind to each other because we can all use some extra kindness in our lives. Bye for now.